Alright, in this video we're going to be reviewing the volume formulas that you learned in 7th grade and practicing some applications of them where you need to use the Pythagorean Theorem. Alright, so let's start by writing down those formulas. So first, a cylinder. The formula for that one is you take the area of the base, which would be pi r squared, where r is the radius of the base, and then you multiply it by the height of the cylinder, like that. The cone is related. For that one, it's this, because 3 cones of the same base area and height fill a cylinder. It's one of those really cool relationships. So this is going to be radius, and I'm going to try and draw them to be the same height. Now the height is not measured along the side over here. That's called the slant height. That's different. The height is measured down through the center. So this one will be pi r squared times height, pretty similar, but then all that divided by 3. A sphere would be, sometimes people kind of draw them like that. Radius starts in the center and goes to any edge. And the volume for a sphere is 4/3 pi r cubed. I love proving that formula. We're not going to do it today because I'm already going to try and cram a lot of stuff into this video. And this isn't one where I'm going to use the Pythagorean Theorem, but I just wanted to throw it back out there at you so that you'd seen it again, because it's technically an 8th grade skill that you learned in 7th grade, so it's worth reviewing. Alright, so let's say you were given a cone and you were asked what the volume is, but instead of giving you the height, they gave you the slant height. Now, if that had happened in 7th grade, you would not have been able to solve because you did not know the Pythagorean Theorem. And you need the Pythagorean Theorem in order to be able to figure out the height. Can you see why that is? So the first step when solving a problem where you know you're probably going to need the Pythagorean Theorem is to try and identify where is the right triangle. Where is it lurking? Where is it hiding? So in this one, the height right here, we know we're going to need that to find the volume, right? So I'm just going to sketch it in. And maybe that can help you see the right triangle, right? It's right here. Now, I like to redraw that triangle separately so that I can make it a little bit less messy. So I'm just going to redraw that yellow triangle over here. Okay? And I know that the hypotenuse of that triangle is 15, because that's the slant height of the cone. And I'm looking for this length right here. I'll call that h, because that's the height of my cone. And then this length right here, they don't directly give it to me, but they give me the diameter. And half of the diameter is the radius. And the radius of the cube is going to be that length right there. So that's going to be 9, because 18 divided by 2 is 9. So now I can solve for h using a squared plus b squared equals c squared, because I know that is a right triangle. I know that because it's a cone. It's a right cone. It doesn't do like a weird slanty thing. It just goes straight up. And then I'm going to plug in my values. So 9 squared plus h squared equals 15 squared. 81 plus h squared equals 225. Subtract 81 from each side. And h squared equals 144. I take the square root, and that gives me 12. So the height of my triangle here is 12, which means that the height of my cone is 12. So now I can plug in to the formula from up here, because now I know my height and my radius. So pi times r squared times height divided by 3 is my formula. So pi times, and now my radius, not 18, it's 9, right? Because diameter was 18 and radius is half of diameter. So pi times 9 squared times 12, because that's my height, divided by 3. Pi times 81. And then I'm just going to do this. I'm going to do the 12 divided by 3, which will leave me with 4. Hopefully we feel okay about that. And then 81 times 4 gives me 324. So 324 pi is my volume, which is approximately 1017.4. Let's try another one. All right, so this time we're going to work with a cylinder. And my question is, what's the length of the diagonal I've drawn here if the volume of the cylinder is 2,500 pi and the radius is 10? So this diagonal is cutting through the center of the cone from the top on one side to the bottom on the other, just like straight through the middle. Okay? And they've given us the radius of 10. They've given us the volume. They haven't given us the height. Our first step is always to identify the right triangle. Where is the right triangle hiding? So I'm going to draw in the right triangle the way I see it. Like that. Okay? And now I'm going to re-sketch that. I don't have a lot of information on this guy yet. I know this is what I'm looking for, right? That's my unknown. I know this is a right angle. I don't know the height. I know the radius is 10, so all the way across must be 20. Okay, but how can I find that height? Well, let's use the other piece of information they gave me. They told me that the volume is 2,500 pi. And if I know the volume formula and I know the radius, then I can work backwards to calculate the height. I can solve for the height. So I'm going to write down my formula again. So volume equals pi r squared times height, because that's the specific formula for a cylinder. Not divided by 3, because this is a cylinder this time, not a cone. And I'm going to plug in what I know. So I know V and I know R, right? So 2,500 pi equals pi times R is 10 squared times height. And hey, look, I've got an equation with one unknown. I can solve for that one thing that I don't know. So pi times 10 squared is 100 pi equals 2,500 pi. The times h over there. I'm going to divide by 100 pi because I want to get the h alone. And that leaves me with h equals 2,500 divided by 100 would give me 25. And pi divided by pi is just a 1. So it's just 25 equals the height. So I'm going to fill that in over here. You can put it over here too, just for fun. 25. I found it. Woohoo! Yay for algebra. And so now I'm going to do the Pythagorean Theorem to solve for x. So this time 20 squared plus 25 squared equals x squared, because x is the hypotenuse this time. So that would be 400 plus 625 equals x squared. So 1025 equals x squared. And the square root, so then x equals the square root of 1025, which can certainly be simplified, right? It's very divisible by 25, it looks to me, and maybe something even bigger. 1025. Since this is a real life example, I'm just going to go for the decimal approximation, which is roughly 32.0. It would round to a 0, so I'll leave the 0 there to show that it's precise to the 10th place. Okay, so the diagonal is about 32.0. All right, for our last example, we're going to try and find the diagonal of a rectangular prism. So, the diagonal, meaning from like one corner of the box to the other. So from this corner here to this corner would be one way to draw that diagonal. Like that. I don't know if you can picture that. If you were looking at an actual box, it would be like from this corner here to this corner down here. Top to bottom, front to back, left to right, just like the opposite side. Okay? Now, it may be hard to see the right triangle right away. Sometimes it is. To me, I see the right triangle. You know that's going to be part of it, right? And then that guy, and then it's going to cut across the middle there. And we know that that has to be a right triangle because this edge right here is going to hit the base at a right angle, and so any line coming off from that would like make a right triangle. So I'll redraw that one separately. Oh, and I didn't give you any dimensions on this. This guy is a 5 by 4 by 3. Okay? So I'll redraw my right triangle. This one is 4 here. This is the number that I'm looking for. That's my hypotenuse of this right triangle. But I still don't know this guy down here. Question mark. Okay, because I don't know this length. But if I look at this length, and if I try and picture that this is actually a cube and not a cube that Ms. Sherman tried to draw on paper, you can see that this angle right here has to be a right angle, right? Because it's a cube. So that would mean that there's another right triangle right here. Like that. So I'm going to redraw that one too, because that one I have 2 side lengths on. That one I can solve, and then once I solve that one, then I can put that there, and then I can solve for that. It's going to be amazing. Okay, so we're going to go. This one is a 3 by 5 by unknown, and that's the same unknown as up there. So let's do this one first. So 3 squared plus 5 squared equals question mark squared? Feels weird. I'll do it. Why not? 9 plus 25 equals question mark squared. 34 equals question mark squared. Square root of it all. And I'm just going to leave this as the square root of 34 equals my question mark side. This length that goes right there is the square root of 34. So I'm going to put that number in up there. Square root of 34. And now I get to solve for x. So I'm going to do square root of 34 squared plus 4 squared equals x squared. 34 plus 16 equals x squared. Oops, sorry. So that gives me 50 equals x squared. Square root, and x equals the square root of 50. So that means that my diagonal, this length right here, is the square root of 50. This little guy right here was the square root of 34. So the diagonal is the square root of 50, which of course can be simplified to 5 root 2, because 25 times 2 gives you 50. All right, practice problem time. All right, your practice problem, this is just like that first example, okay? So if you go back and rewatch that first example if you need to, you are going to find the volume of this cone. I have given you the slant height of 25. I have given you the radius of 7, and I would like you to round your answer to the nearest tenth, please. Good luck.